Welcome to Eagles Concepts Learning Room. In this video, we're going to take you through Science Paper 1 2019, Section C. So we'll begin with question C1. The question reads, a spring with its upper end fixed hangs vertically alongside a meter rule. The lower end of the spring gave the following readings in table C 1.1 when various masses were hung from it. So there you can see the table. We have various recordings here, mass in kgs, readings, the applied force, and the extension. Okay, so B says copy and complete the table for the values of the applied force N and the extension centimeters produced. C, draw a graph of applied force against extension on a graph paper, 4 marks. D, on the graph, show the elastic limit, 1 mark. So the total of each question is 10 marks. You are only required to choose 2 out of the 3 questions provided. And I can assure you, of the 3 questions, at least 2 or 1 will be on graphs. So please pay attention as we take you through the graphical work and the other question. So the solutions. The first question says, state Hooke's law. Now, Hooke's law states that the extension of a loaded spring is directly proportional to the load, causing extension, provided that the elastic limit is not exceeded. So just for stating this one, you have your 1 mark. Now, let me just explain a bit about elastic limit. So elastic limit, as you are putting your masses on the spring there, the spring is expected that it will be extending linearly at the same interval. So the interval will be the same. For example, if the 0 kg mass here, if the 0.02 kg mass extended the spring by 2, we expect that the 0.04 kg also will extend it by what? By 4, and so on and so forth. That's what it means. So now, this elastic limit here, when the spring reaches this point, it means that it can no longer return to its original position. When it reaches this point, meaning when you go beyond this point, the spring is going to be permanently destroyed. That's what it means, meaning Hooke's law will no longer be obeyed beyond this point, as you will see when we plot the graph. Okay, so let's go ahead. B was simply saying, complete the table. So now this is what you're going to do. So now this column is for the masses. So this one, it simply shows that this one 0 kg, it means they didn't put any mass on the spring. So this is the original mass of the spring. So after they had put a 0.02 kg spring, then it had gone to 12 centimeters. Now for us to fill in the forces here, it means we are just converting from kgs to newtons. And the way we convert from kgs to newtons, we use the formula W is equals to mg. Now this W simply means weight. Now because the weight is in newtons, it simply means that it is also a type of a force. So this one is in newtons, the m is the mass, which is in kgs, and the g here is the acceleration due to gravity, and this one can be given as 10 Newton per kg. So 10 Newton per kg. That is the value of G here on Earth. So if we want to convert from mass and taking it to Newton, it means we are simply going to multiply these kgs by 10 so that we have our value. So multiplying 0.02 multiplying by 10, we are going to have 0.2 newtons. Okay, so using this formula, meaning we are going to say the first one is this Newton here. Since we know that this one is in newtons, then this one is in kgs. So let me just give an example of the first one. So we are going to say the Newton here will simply be equal to 0.02 kgs. So this is 0.02 kgs multiplying with 10 Newton per kg. okay, 10 Newton per kg, so that these kgs and that kgs will go, you only remain with the Newton. Then when you multiply 0.02 multiplied by 10, you're going to just move one decimal place, which is giving you that one. So you do the rest, the rest in a similar way. So the 0.04 times 10 simply give us 0.4. We continue, this one will give us 0.6. So we're saying 0.06 multiplied by 10. Then we go to 0.08 multiplied by 10. This one is giving us 0.8. And this one also, they already did this one for us, so it maintains. Okay, now going for this other part, it's extension. Now extension is given by the formula, so I'll just write E for extension. Okay, extension is equals to new length. So I'll just write new length. Okay, so new length minus, so that is the formula, new length minus the original length. So original length, I'll just write it as the NO. So that's what it means. So extension will always be given by new length minus the original length. So in this case, we are saying the original length is 10 here, because notice that before anything was put, the reading was 10, meaning this is the original length of the spring. So the new length in this case, after they put a 0.02, the new length became 4.0. So to find this value, we are simply saying 4 minus 10, and we find the value is 2. Then we go to the next, it will also be 14 minus 10, which is going to be 4. Then 16 minus 10 is going to be 6. Then 17 minus 10, this one is going to be 7. So that is how you fill in the table. Remember, extension here is given by the formula. So extension will be given by E is equals to this one. I'll write as N with a subscript E as new length, with an L, minus NO, which means original length. So when you use this one across everything, you are going to fill in the table like this, and there you have your 4 marks, and here you have your 1 mark. So already that is your 5 marks. Okay, we proceed. The next one, they say we should now plot a graph. So now a few things that you need on the graph is you need a title. So okay, now using these values, you need to plot the graph. So let me just take you back to the question. Here it says on a graph of applied force against extension, draw a graph of applied force. So here it is, applied force against extension. So this one is your formula. This one is your title. So the one which they request you to do is actually the title of the graph. Now this one, it means one thing. The quantity which has been mentioned there, it forms the y-axis. Okay, it forms the y-axis. And then the other quantity which is mentioned last, this one forms the what? The x-axis. So we know that in this case, applied force will be on the y, whereas the extension will be on the x. So let's look at that. So we are saying this table, if you look at it, our applied force, this one is our y-axis. So this is our y, and this one is our extension. So that is how you figure out which one is the x and which one is the y. So having figured out these values, then we are going to plot. Okay, so the first thing that you need is the title. You write the title of the graph there. Okay, so you can put the title and underline it. So title of the graph, then somewhere there you have to write the scale. So you write the scale of your graph like that. Even the title you write, I'm not saying you write the name title, you write the title of the graph and underline that side. Then you figure out the scale. So the scale in this case, we are going to check it out. Okay, since this one is being counted as 0.2, so here we can just have as on the x-axis. So you can write something like on the x-axis. Okay, so on the x-axis, you can use a scale of let's say 2 centimeters to represent. Okay, I'll show you on the next diagram how it is supposed to be done. Let me just try and plot the graph here. So that one there, you can draw 2 centimeters to represent 0.1. So you draw this one as your y-axis, okay? Then this other one is going to be your x-axis. So that is your y-axis. You use a ruler to do this. You draw your x-axis like that. Then the next thing now which you notice is you are going to be saying this one. Let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here on the x-axis 2 centimeters will represent 1. So this is 1, 2, 3, and this one will be 4. Then the next one will be 5. Then the next one is 6. From there we go to 7. From there we go to 8. Okay, then here we are just going to count. Now this is 0.1, so start. This is 0.1. So you figure out how you are supposed to do it. So this is 0.1, 0.2, 0.3 there, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So this point here, that is where we have 1, 0.8, this is 0.7, this is 0.6, this is 0, so this is 0.4, this is 0.5, so let's count 1, 2, 3, 4, 5, this is supposed to be 0.6, then this one here, erase this one, continue. So this one will be 0.7, this one will be 0.8, this one is 0.9, and we have now 1.0. And remember, this side here is supposed to be force, so you label your axis. This one is supposed to be the applied force in newtons. So this is applied force, then you say in newtons. Then at the bottom also you do the same extension. So you label your axis. This is the extension. You write your extension there. So extension in centimeters. So just for doing this, they are marks. So this 0.5, 0.5 plus 1, 0.5, 0.5. So already you have 2 marks just for doing what you have done. Then the next thing that you're going to start doing, you're going to start plotting. So the next thing here we have 0, 0. Then the next thing we have is 0.2, 2. Okay, so this one we have, it's 2, 0.2. So 2, 0.2. Then the next one is 4, 4, 0.4. So this is the one here, 4, 0.4. And the next one we have 0.6, 6, or 6, 0.6. So 5, so 6, 0.6. Okay, so 6, 0.6. This is the point here, 6, 0.6. Then the next one, this one is supposed to be here, 4, 0.4. So we can erase this one. This one, this point here, 13. So this one. Then the next one we have is the 7, 0.8. So 7, 0.8. So now 0.8, this point here. Then thereafter we have 7.5, 1. So 7.5, 1. Now the 1 is somewhere here, and the 7.5 will be here. You just count this 1, 2, 3, 4, 5. So this is the 7.5. So as you can see, using your ruler here, you can really tell to say this one here is a straight line. So up to somewhere there, this is a straight line. So meaning it was obeying Hooke's law. Then from there, you can tell to say, see, not a straight line. So this is what you're going to come up. So now, here where the graph started changing, this one is what you're going to call the elastic limit. So get the elastic limit, get the elastic limit like that. Okay, so you are done with your graph. Now you have labeled everything, and that is the way it's done. So you are now, your graph is actually supposed to be like this one. So applied force newtons. This one here, there's a mark there. Then also on the scale, there's a mark. On your title there, there's a mark. Then for plotting these things that you are, the coordinates here, there's a mark there, there's a mark there, there's a mark there, there's a mark there, and there's a mark. And even for the line, also for drawing this line correctly, there's a mark. Even here, there's a mark. Then also for labeling your axis, this one is supposed to be the x-axis, there's a mark. And you can get the whole 4 marks. Never forget these rules on how we deal with graphs in science. Okay. C2. The question reads, 2 lamps S and T are of resistance 200 ohms and 300 ohms respectively are connected in series with a 240 volts mains as shown below. So this one, first things first, this one is a series connection. It's a series type of a circuit. So in a series type of a circuit, here are a few things that you are supposed to know. You are supposed to know that current, which is given by the symbol I, so there are rules. These things are called rules. So current is the same throughout the circuit, is same. So current is the same throughout the circuit. And then number 2, you are also supposed to know that voltage, total voltage is equals to Vt, which is equals to V1 plus V2. Now, this simply means that voltage is not the same, meaning the voltage in here is different from the voltage in here. That's what it means. So to find this total voltage, we need to add the voltage in here plus the voltage in here. Then we are going to know the total voltage. But the current is the same. So if I'm to measure current here, current there, current there, current there, current anywhere in the circuit is the same. If the current here is 2, even there it will be 2, even there it will be 2, and there it will be 2. That's what this will mean. Then the resistance RT is just given by RT equals to R1 plus R2 and so on and so forth. So these are the main rules that I thought people should know about, and they are important that you know them before you can start the calculations. So the first one, they are saying calculate the current at the point V. So the first thing that you're supposed to do here, of course, is collect your data. So in collecting your data, you are going to know that the Vt here, so collecting, let me just collect the data right here. So data, just collect right here where people can see. So data, we have the Vt, the total voltage in here will be given as our 240 volts. So we have our 240 volts. Then RT. Okay, so now what we have been given here is we have RS, meaning resistance in the S, which is equals to 200 ohms. Okay, so this one is 200 ohms. Then we have got the R in the T, not the total resistance, but just R in this about T. So this one, which was equal to 300 ohms. So this is the data that will be given. Then the first question is asking us to calculate current at V. So the current I here, we don't know. Now, because current is the same in the circuit, meaning we first of all need to know the formula, which says current is equals to, so A1 here, current is equals to voltage over resistance. That is, when we find that one, current is equals to voltage over resistance. Now, since current is the same here, we first of all need to know the total resistance. So total resistance here, RT, will be given by, since the formula we've already figured out that it's R1 plus R2, so we're just going to add 200 plus 300. So the 200 plus 300, it will give us the 500 ohms. So you add 200 ohms plus 300 ohms, 200 plus 300 ohms. This one will give us our RT as 500 ohms. So this is what we have. So therefore, current, so the answer for A1, therefore, current is equals to the voltage, which is 240 volts, divided by our 500 here. So we punch on the calculator there, and we have our value as 0.48. So we have 0.48 amps. Units are very important, so this is 0.4 amps, and we have our answer there. Okay, A2 is simply saying calculate the potential difference across P. Now, potential difference across S and lamp S. So now potential difference is the same as the voltage, and we know that voltage will be given by the formula. If you just change this formula, so voltage will be given by voltage equals to IR, meaning current multiplied by resistance. Now we know that current is the same. Okay, current is the same. So we are going to use the same current we have found there, which is 0.48 amps, and then multiplied by, so current is equals to 0.48 amps multiplied by the 300 ohms. Then our answer here is going to give us, 96 volts. 96 volts. And that is our potential difference. Okay, we go to question B. Let's answer it from this space here. Question B, this one simply says, draw a circuit diagram showing resistors S and T connected in parallel. Okay, so in parallel now, you need to know, okay, we have that one, the positive and the negative. Then we are going to have a situation, draw it nicely. So we're going to have a situation like that. Then organized in parallel, it should be like that. Okay. Then the next one will be there. Okay, so it will be like this, like that. Then it will be something like this. Okay, this is what you expected. Now we have put it in parallel. So this one is the S, and this one is the T. So this is how you can actually draw these things. And then the beauty about this thing is that they will have separate switches. This one, you make sure you can put a switch somewhere here. So you put a switch somewhere here. Then this other one also can have a switch somewhere here. So these, they've got separate switches. So this one is how you can draw the parallel circuit. Okay, so it was saying draw a circuit diagram showing resistors S and T connected in parallel. You just done that and see. Using the diagram in 2B, calculate the current through lamp S and lamp T. Okay, the current through lamp S and lamp T. Now, like we were saying, in the parallel circuit, there are also rules. One of the rules is that voltage is the same throughout. So voltage is the same throughout. Okay, same. So here, since we are given a voltage of 240, a voltage of 240 volts, it means that through bulb S there was 240. Also through bulb T there was also 240 volts. Okay, so this one, it has a resistance of to S 200. So here resistance they've given us 200. Then this other one given us resistance of 300. It means that to find the current, because current is not the same. Okay, so current in here is not the same. So the current in here and there is different. So we are simply going to say to find the current, you know that current is given by voltage over resistance. This one will be equal to, so the voltage is the same everywhere, so it will be 240 volts. 240 volts divided by 200, and our answer for this one, punching on the calculator, is going to give us 1.2 amps. So 1.2 amps. Okay, then we go to the second one, also current, because so this is current in S. Then here we are finding now current in T, which will be equal to 240 divided by 300 ohms. So this is 300 ohms. Volts there and there is supposed to be ohms. Okay, so this one is going to give us, so 240 divided by 300 is giving us 0.80 amps. So you have found your answer there. And the next, they are saying find the total resistance of the circuit. Now, for the total resistance, RT, it has got its own formula for the parallel, which is given by 1 over R1 plus 1 over R2, and so on and so forth. But if there are only two resistors, you can use the formula RT is equal to R1, R2 over R1 plus R2. So in this case, it will be equal to our R1, which is 200. So that is 200 multiplying with 300 over, so multiplying with 300 over 200 plus 300. Okay, 300. And the answer in this situation, punching on the calculator, it will give us 120 ohms. So this is 120 ohms. And there we have our final answer. Okay, so the question reads, give 2 reasons why lamps are preferably connected in parallel in ohms. Okay, so the reasons are very simple here. So number one, I can say number one reason is that number one, damage caused in one bulb cannot affect the other bulb. Then number two is that parallel circuits, they have independent switches. So parallel circuits have independent switches. The number one is that the damage caused in one cannot affect the other bulb, unlike in the series. Okay, so we go to the last question of section C, which is C3. The question reads, figure C 3.1, below is the diagram showing a bowling ball as it rolls down an incline for 5.0 seconds before reaching the horizontal ground. So this is the bowling ball that is being shown here, and it is moving from up all the way up to down. So the changes in gravitational potential energy of the bowling ball as it rolls down to the horizontal ground are shown in table C 3.2 below. So this is the table. And the first question says, state the law of conservation of energy. Now, the law of conservation of energy simply states that energy can neither be created nor destroyed. It can only change from one form to another. Okay. B, using the values in table C 3.2, draw a graph of potential energy against time. Okay, so it's very important that you understand that this one here, graph here, a graph of potential energy against time, that is the title of the graph. Now, not only is it the title of the graph, but it is also trying to show us something here. So not only is it the title of the graph, but it is also showing us which quantity to put on the x-axis and which quantity to put on the y-axis. So now the first one which is mentioned is always on the y, and the last one to be mentioned is always on the x. So that is the general rule that you can follow. So thereafter you can figure out the correct scale to use. So like in this instance, let's look at this graph. Okay, so here that's the title of the graph of potential energy against time. Then we also need now to have a scale by the side here. That is the first thing that is going to help us determine the graph. So you can write the scale as on the x-axis. Okay, on the x-axis. So you write it like that. On the x-axis, 2 centimeters. 2 centimeters is representing 2 centimeters is representing 1 second. Okay, which means that you'll be counting in 1 1 1. So 1 plus 1 2 plus 1 3 plus 1 4. So that is what it means. Then on the y-axis, so you write on the y-axis, you say 2 centimeters is representing 1 joule. So this one is 1 joule, and there we are done with the scale. So we already have a mark for that and a mark for that. So you also write the axis name here and the axis name there. So you have a mark for that and a mark for that. Then you are going to plot your graphs. Then you're going to plot your coordinates there. So you have this coordinate here. You also have that coordinate there. You also have this coordinate there, and you have this coordinate there according to what you've been given in the table. And then you finally have the 5, 0. So you connect it with the straight lines there. Okay, so we go to the next question, which says calculate the height h of the inclined plane when the potential energy was 9 joules if the mass of the ball was 900 grams. So data collection here, if we can collect the data, so look at the data that will be given. So from the data that will be given, here we have the energy itself. So we have potential energy, which is equals to 9 joules. Then from there, we also have the mass, which is equals to 900 grams. Now we have to convert this one from grams to kgs by simply dividing it by 1,000. I think this is something that we know by now. So this one will give us 0.9 kgs. Okay, so it has become kgs. And thereafter, what else do we have? Okay, so we have the mass, we have the shunt, then they are asking for the height. So h is equals to question mark. So here the formula to use was potential energy PE is equals to mgh. So meaning here we have the potential energy, which is 9 joules. So we are writing 9 joules is equals to that is the mass now is 0.9 kgs multiplying with, so 0.9 kgs multiplying with so the G here is 10 Newton per kg. So this is 10 Newton per kg multiplying with the H. So here we are going to have 9 joules is equal to, so 0.9 times 10 is 9, 9 times H, that gives us 9H. So we divide by 9, then this side we divide by 9, and we finally have our H as H is equals to 1 meter. So our height is actually 1 meter. This question says, using the graph, estimate the kinetic energy of the bowling ball at time 2.5 seconds. So this one, you just go to time 2.5 seconds, which is here. You draw a dotted line, then where it meets the slope here, you go this side and pick up the value, which was 1, 2, 3, 4. Okay, so this was 4.5 joules. That is our answer. Then the next question says we should also find the energy at 4 seconds. So we go to the 4 seconds, draw a dotted line like that, and get the value here, which was actually 1.80 joules. And that is how you deal with the graphical work. So make sure you have the title of your graph, you have the scale, you label the axis, and you choose the appropriate scale to ensure that your graph at least big enough, it is filling about 75% of your work. Thank you for listening to this video. Till next time, do not forget to subscribe.